Okay, so we've looked at finding the area under the curve using Riemann sums. We've done an exploration. And so now we're going to compute definite integrals with a lower and upper limit. And so we won't need plus c at the end. It turns out that the function that you're integrating is a rate of change function, and the function that you create after taking the antiderivative is a total function, like a cost function that finds the total cost when you know the number of items, or a profit function that finds the total profit when you know the number of items, or a revenue function that finds the total revenue when you know the price. And so these antiderivative functions, what you're doing is you're finding under the area under the rate of change curve. So we're going to use the fundamental theorem of calculus to find the area and move on from the pre-calculus method of finding the area under the curve with Riemann sums. So we've already looked at the investigation, page 77 through 80, and we found that the fundamental theorem of calculus tells us to first find the antiderivative and then evaluate it with the upper limit and the lower limit and then subtract the two. It's not really set up differently, but we are going to look at Excel and see how to solve those using Excel. So what you'd want to do here, if you want to integrate 3x squared, is in Excel, for some reason we just like to do horizontal rows for this. So we're going to put the lower limit 0 and the upper limit 5. And then here, you can't see it, but the antiderivative is what you would type in here. So you would type in here equals 3 times x cubed divided by 3 right here, and then hit enter, and then you drag it over here. And so what Excel is doing is it's inputting the 0 into the antiderivative here and the 5 into the antiderivative here, and then FTC stands for Fundamental Theorem of Calculus, and that's our way of saying we're getting ready to find the area of the curve. We're getting ready to subtract. So we subtract the upper limit's antiderivative value minus the lower limit antiderivative value, and we have that. Okay, so for the second one, this is a polynomial function, and I don't normally mind if you take the antiderivative of a polynomial just directly into Excel. There's usually people don't mess that up, so that's what I'm going to do here. The lower limit is 2, the upper limit is 5, and then right here I'm going to say antiderivative, and the antiderivative of x squared is x to the third power divided by 3, and there's no trouble here because your calculator, your Excel is actually going to use order of operations. It'll raise this to the third power, get an answer, and divide by 3. So it's okay to type it in this way. Plus 5 times, because a constant comes down, x squared divided by 2 plus 7 times x. And then we'll drag that antiderivative to the right. And then the FTC is what we use to say we're getting ready to find the area under the curve by subtracting the upper limit's value minus the lower limit's value. Okay, so there's that one. Now this one requires, and this one requires, for you to put the antiderivative on paper before you try to type it in, I suggest. So let's do that. Okay, so we want to take the antiderivative of this before we type it in. So the antiderivative, this is a linear power here, so I can use the shortcut. So this would be constant comes down and divide it by the derivative of that, which is negative 1 times e to the negative 1x. We don't need plus c because we're evaluating it from negative 8, from negative 8 to 0. And I'm going to show you how to do this in Excel, but I do want to note that WebAssign on some of these wants the exact answer. So I'm going to go ahead and do this, find the exact answer. So remember what you do is you put the upper limit in. So that'd be negative 5e to the negative 1 times 0 minus the lower limit, which would be negative 5e to the negative 1 times negative 8. So negative 1 times 0 is 0, so e to the 0 is 1. So this is negative 5. And then minus a negative is a positive 5e to the positive 8. If you type that into WebAssign, it will be happy. So on a lot of these FTC problems, if you want to try to do it by hand, or it won't give you a correct answer. It won't like the rounding error. So the second one, the integral from 1 to 9 of 1 over x plus 10 is the natural log of absolute value of x plus 10x, and then we're going to evaluate it from 1 to 9. So if we get the exact answer, that's going to be natural log of 9 plus 90 minus natural log of 1 in parentheses minus parentheses natural log of 1 plus 10. So that's natural log of 9 plus 90 minus natural log of 1 minus 10. So that's natural log of 9 minus natural log of 1 plus 80. And that's the exact answer. We're going to use Excel to get the approximate answer. Okay, so now we have taken the antiderivative on paper. I can type it in. So my lower limit is negative 8. Upper limit is 0, and I'm going to calculate the FTC. I'll type in antiderivative, and the antiderivative for 5e to the negative x is negative 5 times exp to the negative 1 times the cell reference. And so now I'm going to drag it to the right one time, and those are my antiderivatives evaluated at negative 8 and 0. FTC means I'm going to take these values, my upper limit value minus my lower limit value, and get the area under the curve. This one, lower limit is 1, upper limit is 9. FTC, take the antiderivative, and the antiderivative is natural log ln of x. You don't have to put in absolute value in Excel because our domain is always going to be positive numbers, so there is no problem there. Plus 10 times cell reference. Drag it to the right, equals upper limit value minus lower limit value, and you have 82.2. Okay, so let's look at our first word problem where we're going to use the FTC method. It says oil is being pumped out of a well at a rate of R of t equals 503.7 e to the negative 0.142 t units of oil per month, where t is measured in months. Question 1, it says approximately how much oil is pumped out during the first 14 months. And then it says calculate the total oil underground assuming the well is closed when the rate drops to 0.005 units of oil per month. So just like the first time we did a word problem with Riemann sums, it's so important to take stock and understand what your variables are. And so again, we're missing the prime here, and so that's not what you're going to be looking for. T is measured in months, so T is time in months. I feel like I need to make this a little bit bigger. Maybe. Okay, and notice that R of t is not a just a regular function. It is a rate of change. So the word rate's a huge hint, and then the units are a huge hint. So R of t is a rate. It's units of oil, y units per x unit, which is months. So what that means is if I take the antiderivative of this rate, anti R of t, then that's going to give me total units of oil. So if I know the number of months, I'll know the total units of oil when I take the antiderivative. And so this antiderivative is, it's got a shortcut. You take the constant 503.7, you divide it by the derivative of this power because it's a linear power, and then e to the negative 0.142 t stays there. So if we want to know how much oil is pumped out during the first 14 months, then I can set up my t for time in months, and I want to know from 0 to 14 months the total amount of oil, which would be anti-R of t. So the antiderivative would be 503.7 divided by negative 0.142 times exp to the negative 0.142 times t. Then FTC is my Q that I want to, remember this is area under the curve, so we're finding the area under the curve for our 14 months minus the area under the curve for 0 months, and don't let these negatives bother you at all. When you subtract it out, your answer is going to come out to be something reasonable. So we know that 3,061.33 units of oil have been pumped out. Next question, it says calculate the total oil underground, assuming the well is closed when the rate drops to 0.05. So this time they want us to use the rate function, and I'm going to put that in there. That's 503.7 times exp to the negative 0.142 times t. And I typed it too fast. What did I do wrong? It corrected it for me. Okay, and so what I want to do is I want to figure out when this when the rate drops to 0.005 units of oil per month. So I'm going to look at a few values. T is time in months, so let me look at least the first 12 months because I have to look for trends. And if I graph it, let's see if I can see a trend. All right. I was worried that there would be an increase and then a decrease, but this, if I'd have thought about what kind of function this is just completely decreasing. So that means that I can just go ahead and goal seek R of t, the rate. I want the rate to go to 0.005 units per month. So if I goal seek this to 0.005 by changing this cell, it'll tell me the month when the rate of oil per month drops below 0.005. And that's month 80.77. So now I can answer this question. It says calculate the total oil underground. So that's going to be this. Oops. Copy that. It's going to be this, except instead of 14, I want to know what happens when I go all the way out to 80.77668 months. I have the antiderivative here, and if I subtract, I know that the total units of oil that this well holds is 3,547.15 units of oil. Okay, let's look at another example. It says your investments are increasing in value according to the function. And I'm going to go ahead and start typing up what things are. So T is equal to years, and V is dollars per year. So the word rate isn't there, but the units on this V function is dollars per year, y per x. So that means that this V of t function is a rate of change, and it's in dollars per year, which means that the antiderivative of this v of t is just going to be dollars. And again, I can't really draw in this Excel file, but I want you to visualize. Remember Riemann sums, v of t was the vertical height of the rectangle. Let's pretend it was here. So that would be dollars per year. And this delta x would be x, which would be years. So if you're doing dollars per year, let me just show you. I will insert it. Alright, so if you look at the units, dollars per year, that's my vertical, times years. The years cancel and you're left with dollars. That's what's going on right here. This is a rate of change. This is the area under the curve. So the area under the curve, if we think of Riemann sums, is vertical dollars per years times horizontal years. So it makes sense that the units on the antiderivative would be dollars. Okay, it says you will retire when your total investments reach $1 million. So how many years before you retire? What we want to do is we want to understand that we need the antiderivative for sure, because we want to, you have dollars. It says how many years. So what we don't have is the upper limit. Now there are a bunch of ways to do this problem. There's 3 ways that I know to do this problem. I'm going to do this problem this way. I'm going to let t be 0, and I'm just going to leave my upper limit blank. And then my anti-v is 10 divided by 0.095 times exp to the 0.095 times t. And then I'm going to drag this over and I put FTC down here. And the FTC is the area under the curve. And that's the interesting thing about this problem, is I want $1 million. So I want this value right here to be 1 million. Okay, well, nothing happened. Well, what I have to do is I have to understand how this FTC comes about. This FTC comes about from subtracting the upper limit value minus the lower limit value. And I want this to be 1 million. So this is a pretty fancy way to goal seek, but we can goal seek this FTC to 1 million by changing the upper limit. And there you go. If you look here, there's a bunch of different ways to do this problem. First, you could put in the original rate of change and the antiderivative, and if you do it this way, the antiderivative at 0 is 105.26. So if I want to know the t here without using the FTC method, I would actually want to goal seek to $1,105.26. So there's that way. And then this way would be to write an algebraic equation, which would be 0 to t, we don't know the upper limit, 10 e to the 0.095t dt equals 1 million. Take the antiderivative and then apply the fundamental theorem of calculus where you put the t in and the 0 in, and you get this equation, add 105, and I stopped, but you could multiply both sides by the reciprocal, take the natural log of both sides, divide by 0.095, and t would equal 96.41. So that one's kind of a tricky one. Alright, let's look at this one. This one says a company estimates that its daily sales will grow continuously at a rate given by this function. I did put the prime in here, but you would know because it's a rate, and S prime of t is sales rate in dollars per day. So again, T is days. This is dollars per day. So the antiderivative would just be dollars. Dollars over days times days equals dollars. So the Riemann sums are always kind of in my mind to help me understand how the units work. So what I want to do here is T is days, and I want to know the accumulated sales for the first 5 days. So from 0 to 5, the antiderivative of s prime of t is just s of t, and the antiderivative again is 20 divided by 0.35 times exp to the 0.35 times t, and I'm going to put FTC right here again. Okay, so this minus this is 271.692. So what is this? Well, again, the antiderivative of sales rate in dollars per day is just dollars. Okay, so this is dollars. This is the total sales, or the accumulated sales for the first 5 days. Then it says find the sales from the 2nd through the 5th day. So that is going to be the same problem, except now the lower limit would be 2 and the upper limit would be 5. So that would be 213.76, or $213.76. Okay, this one says find a model. I've done that one. You can try that if you want. Now let's see. This is another E function. This one is an actual find the actual area, so I'm going to skip that one. Alright, this is the last one we'll do together. A company has a marginal profit in thousands of dollars per unit modeled by this function. The prime is there, but that's not the hint. Marginal profit, that means this is a derivative. Units, thousands of dollars per unit, where Q is units. That's a rate of change. That's a derivative. And it says find the total profit from the production and sale of the 101st unit through the 800th unit. So Q is units, and we want to know the profit from 101st Q to the 800th Q. We know this is a rate of change, this is a derivative, so the antiderivative, which would be -2 times Q squared divided by 2 plus 980 times Q. And then FTC would be this value at the upper limit minus the value at the lower limit. Okay, so we're going from dollars in thousands of dollars per unit, times units. If we think about Riemann sums, dollars per unit times unit is just dollars. Area under the curve is dollars, but it's in thousands of dollars. So I'll take this value, times it by 1,000. That's a very large amount. That's our amount. $55,221,000 is the total profit from the production and sale of the 101st unit through the 800th unit.